Here are two Kenwood TS700As, Hamfest specials. Got them from a guy. He said he wanted to try to get one good working unit from the two. Use one as a donor unit. This is unit 1 and unit 2. Unit 1 was a fairly easy fix. It had a bad power transistor, which here, Q1, you can see a pass transistor. It's a 2SD235 that had an open collector base junction in it. So I replaced it with a better transistor. The original was rated at a collector emitter voltage of 40 volts, 3 amps, power dissipation 25 watts. I replaced it with a 2SD525, which had a 100 volt collector emitter voltage and 5 amps with a 40 watt collector dissipation. So this unit is actually working. Although, as you can see, I've got some lights out I got to replace. Anyway, unit number 2 here is a different story. This one has had all sorts of problems. And I fixed a couple of them. One of them was I've had some bad capacitors in the power supply. Quite a few of them I've replaced. You can see here. You can see the original capacitors in different sizes. This one was replaced with a newer one, a lot smaller. But this one I'm still having trouble with, and I'm not sure if I'm going to be able to fix it. The main problem is on the heterodyne board here, and I'll go into that in a minute. Here's a modification that was done. This cable here runs up to the RL1 on the bandpass filter unit on the other side, and normally would come down here and connect directly to the BPF terminal on the receive noise blanker board. But what they've done, they've removed this cable from the noise blanker board, the RXNB unit, and they've connected another cable that runs underneath to the other side to another board, an add-on board, and then that board comes out on this cable and goes to the BPF terminal. So where does this cable go? It goes to this board, which I have no idea what it is. It had a capacitor, a variable capacitor similar to this one here, which was actually shorted. I removed it. It's got a transistor here. It gets power. It connects up to a ground here on the marker board, and then it receives power through this connector. And then the output of that comes back around through this cable to the marker terminal on the RXNB unit. So I don't know what that does. It's some kind of an amplifier. What I'm going to do now, I'm going to put it back to stock factory where this cable was connected directly here. This might have been some kind of a preamp, it looks like, that someone had added originally. And since that's defective, it had a shorted cap, I'm going to reconnect this cable back. And we'll go from there. And I'll have to do a little research to find out if that was a modification someone came up with years ago. This unit is over 44 years old, so who knows how many hands have been in this unit. There's a big difference between the 700A and the 700 in the heterodyne unit. And I was looking at the manual for the 700. They have a completely different method of switching in the different crystals for the different band segments. Surprisingly, in the 700A service manual I have, in the circuit description, they left out a description of the heterodyne unit. There's no mention of it, at least that I could see. But anyway, this is a schematic of the heterodyne unit and the 700A, and apparently how they select the different sections of the band here, 144 through 147. S8 here switches to ground each of these points, and as it does that, it connects ground through a 1K resistor. And this point here is 9 volts, positive 9 volts comes up through L8. So what it apparently does is it forward biases these diodes in series here for each segment. For example, in 144 segment, it would ground this point, and that would forward bias D1 and D2, which would connect X1 through L7 into Q1 in the oscillator here, which is interesting. So evidently there were some big changes made. Now something else I found which had me confused for quite a while, and let me magnify this a little bit so you can see it. If you look at Q2, now in the service manual, when you're adjusting through these sections here, these transformers T1 and T2, it says to connect a frequency counter to test point 1, which is right here. And that's fed, it's tapped off the secondary of T2, which feeds the balance mixer here, pin 11 of Q3, which is an IC. Anyway, it's coupled up through C31 and out through this capacitor, looks like it's C33, to test point 1. But it's got this transistor here that appears to be floating in space here. You've got it looks like it's a common emitter amplifier. You've got an emitter resistor here, and you've got a base bias resistor here, but there's no collector voltage. And if you look at test point 3, this is a coil that test point 3 is just hanging in midair. So this transistor is basically not turned on. Well, I try to measure at test point 1 with a frequency counter, and of course I couldn't measure any signal there. What I had to do was connect a jumper lead from test point 3 to 9 volts, and that biased Q2 on and allowed this transistor to amplify the signal from the frequency counter. Why there's no mention in the service manual to that, I don't know, but when you look at this, it's kind of strange how they just had this thing hanging in midair, and evidently they just used that for adjusting the transmitter or the heterodyne unit, and then when you were done you disconnect it. There might have been some interference problem if you amplified it, I don't know. But that was confusing for me at first. This is test point 1 on the het board, and to bias that transistor Q2 on, you need to connect a jumper from 9 volts, which would be here, to the top of this coil here. You can see it, and that's L9. And when you do that, you bias the transistor on Q2, which allows you to measure the frequency with a counter. That wasn't, like I say, that wasn't in the service manual. So if you get to that point on one of these things and you can't measure anything at test point 1, be sure you bias that transistor on by jumpering from test point from 9 volts to that coil L9, test point 3. This is test point 3. the little loop at the top of this coil here. So test point 1 where you measure your frequency counter, test point 3 where you jumper 9 volts to activate the transistor. Okay, this point here is 9 volts, and it comes up through R38, which is a 10K resistor. And if you look here, it comes over and feeds through two 470K resistors through these two varactors, which are in the tuned circuits of T1 and T2. The secondary of T1 and the primary of T2. And apparently that forms a divider here which changes the voltage, the reverse voltage on these two varactors, which affect the tuning of this secondary of T1 and the primary of T2. And this is where my problem is. I'm losing the signal here on the primary of T2, and I haven't been able to find out why I'm losing the signal here. I've removed T2, that's okay. I don't know if there's a problem with these varactors. I don't have any of these particular units. The varactors they're using in the circuit is a 1S2208, and I don't have anything equivalent to that. So I'm not sure why this is evidently being pulled down here. I'm losing the signal. If I can figure out why that is doing that, I'll maybe update this video, but for now I'm at a loss here on why I'm losing the signal here. So I pull Q1, which is a 2SC388A. I pull that out and I measured a real low beta of about 30. It should be a lot higher than that. And this is the original transistor. And I replaced it with a 2N2222A right here. These T1 and T2, these were the two transformers that didn't seem to tune right, and then they ultimately feed this IC mixer here, Q3. I'm still getting intermittence here between Q1 and the mixer. The integrated circuit mixer is Q1 here, and the mixer's located under the shield. And I've got a few solder connections in here that look a little flaky, so I'm going to redo the solder connections. Actually, there's a number of them on here that look like they're crystallized, so I think while I have the board up, I am going to resolder some of those connections. Anyway, if you take one of these apart, here's one of the problems with these units here. Unlike the Yaesu, all these wires that are connected, you can flip the board up to work on it underneath, but you can only do it so many times before you start breaking these wires off. So that's another thing you have to watch on this. This radio here of the two, this one's turning out to be a real pain. Lots of problems with it. Well, we'll see if this will help. Anyway, stand by. I'm going to measure with a scope here on T1. If you look at the oscilloscope, I've got signal here. I'm going to look on the output of T1. I also got signal. Now I'm going to look here. So I've got signal on the primary and secondary of T1. Now here's C26, which is a 0.5 picofarad, I believe. I'll have to look in the data here. Anyway, I need to find it again. Okay, here is the input of that capacitor. I can get the probe to stay here. I got signal. Well, there we go. And on the output, I lose my signal. So the signal's lost in here. There's a diode here, D26, which could be affecting this. I'm going to have to isolate that. But anyway, it looks like this is where I'm losing the signal. We don't have the signal on the mixer input, pin 11 here. Pin 5 is fine. So the next step is to determine why we're losing signal between T1 and T2. If you work on one of these units, one thing, if you look on the diagram here, the board layout, Q1, which they show as a 2SD235, which I replaced with a little better transistor, that's mounted on the back here. And they use the back of the chassis as a heat sink. And that's leads from that transistor run over onto the board here, and you can see where they mark it on the board: base and collector, which goes to 9 volts, and the emitter goes over here to 20 volts. It's basically a pass transistor. Look at these old microphones. Kind of neat. Anyway, this is the unit that's working. As you can see, test 1 2 test, testing 1 2 3 test. That's transmitting and receiving. Testing 1 2 3 test 1 2 3 1 2 3. I'm going to wrap up this video so it doesn't get too long. What I need to do next, I'm going to replace the lamps in this unit with LEDs to illuminate the meter, etc. I'm going to go through a full alignment on this one too. This is outputting, and it's actually receiving also. This unit here, I don't know. I'm going to have to try to dig into why that heterodyne unit is not operating properly. It's somewhere in the area, like I say, of T1 and T2. I lose the signal at this point here. I'm not sure why. Something is pulling the signal down there. I'll have to look into that further. If I can figure it out, I might do another video on repairing the second unit. Otherwise, I may just keep that as for spare parts, or if I find another one at a hamfest, they tend to follow me home. Although I like the newer units that have an actual digital display on them, a little nicer to use. But these are nice units. They're very well made. But if you pick one up at a hamfest, you're probably going to have a lot of stuff to fix on them. They're getting pretty old now. I think these go back to, I believe it's late 70s sometime. So anyway, that's it for this one. I'm gonna end this now, and hopefully we'll see you in the next video. Thanks for watching.